Here's the second part to our rock lab, and we're going to investigate sedimentary and metamorphic rocks in this video. Remember, we already looked at igneous rocks, and if you took the kit home from the PCC campus, you have these igneous rocks, these sedimentary rocks, and these metamorphic rocks. And I strongly encourage you to look at those as you see the videos and try to examine features that are being described in the videos. We left off by completing the igneous rock chart, and the next 2 pages introduce sedimentary rocks. So I'm going to blow these 2 sections of text up. Here we go. So sedimentary rocks are divided into detrital and chemical categories, sometimes biochemical if life is involved. Detrital sedimentary rocks are made of fragments of broken material. Physical weathering breaks rocks down into smaller pieces, and if those pieces get made into a rock, it's called detrital. Sometimes it's called clastic. Chemical weathering produces the material that makes chemical sedimentary rocks. Chemical weathering often dissolves or alters minerals so that ions end up in solution, and then those ions are once again turned into a solid by the action of precipitation. Compositions of sedimentary rocks include clay minerals, quartz, calcite, and if you have calcite, you have a limestone. There are lots of different kinds of limestone. Some of them are made of something called dolomite, but we're going to just focus on the calcite ones. And the calcite ones all react with hydrochloric acid, so it's an easy way to tell if you have a limestone. There are evaporate minerals like halite and gypsum that we've learned about as minerals, but when they're in large deposits, we call them rocks. And then altered plant fragments, which typically form a sedimentary rock called coal. Sedimentary textures basically mirror the 2 types of rocks that we described up here. There are clastic textures, which are made of clasts or fragments, and there are non-clastic textures, which are somehow made from precipitation of ions in solution and tend to form a crystalline rock. Here's the sedimentary rock identification chart, and you can see we have 2 main groups, detrital and chemical. And detrital, again, can also sometimes be called clastic. We'll talk more about this chart in a minute. The next part of the lab asks you to look at these pictures and answer some questions. So this is important. On the top, we have some examples of common detrital sedimentary rocks. They include conglomerates, breccias, sandstones, arkoses, which are also a type of sandstone, siltstones, and shales or mudstones. All of these have one thing in common, which is that they are made of pieces of pre-existing rock. Now that's pretty obvious in some of these, but these here look so fine-grained you can't really see other features. Now there's a fossil in here, but that doesn't count. But indeed, each of these are made of sand-sized, silt-sized, or clay-sized particles. So all of these have formed from physical weathering. Down here, we have those chemical and biochemical rocks that have formed from precipitation. There's a whole group here that are made of calcite. And again, those react with hydrochloric acid. They are all considered limestone. Some of them have the word limestone included in their name, some of them don't, but technically they're all types of limestones. These 2 here are evaporates. They form by evaporation. We have rock salt and rock gypsum. Now we learned about salt and gypsum when we learned about minerals. An easy way to tell about salt is to taste it. It's very salty. And gypsum is very soft. You can scratch it with your fingernail. We then have these 3 microcrystalline quartz sedimentary rocks. And just like microcrystalline limestone, they form by precipitating, in this case, silica out of solution. Up here we precipitated calcite out of solution. We looked at flint and agate when we looked at minerals. Bituminous coal is a type of coal that forms in sedimentary environments. This entire image of rocks has a number of questions that are 1 through 10, and they're on 3 different pages, so I've tried to piece them together here. I'm going to answer a few of them for you. Number 1, what characteristic can be used to distinguish sample A from sample B? Here's sample A, a conglomerate. Here's sample B. And frankly, the answer is given to you right here. Conglomerates have rounded pieces in them, whereas breccias have angular pieces in them, and that's because they formed in different environments. So the answer to number 1 would be that rock fragments are rounded or angular, or you can write it however you want, but that's the difference. Number 2 says, list the name or names of chemical sedimentary rocks that clearly exhibit a clastic texture. Now this is a little bit tricky because we said there were clastic or detrital sedimentary rocks and chemical. So how can we have chemical that are actually clastic? Well, you have to look at the rocks that are here. Are any of these made of little pieces? Well, in fact, this one right here called a coquina, here's a close-up, is made of little bits of shell. You can barely even see any cement. It's just pretty much 100% shells. And so even though this is a chemical sedimentary rock, it's actually biochemical because shells come from organisms. It is also clastic in its texture because it's made of little bits and pieces of other things. So coquina is the answer for number 2. Number 5 asks you to compare and contrast the fossiliferous limestone and the coquina, I and J. So both of these are made of shells, but the coquina has almost no cement, right? The shells are all touching each other. This limestone here has shells, but you can see there's a muddy matrix between them. So I'll let you put that in your own words, but that's kind of what I'm looking for there. The rest of these I think are pretty straightforward, except I'll jump to number 10. What mineral does sample D contain that gives it a pinkish color? So here's sample D. It's one of the detrital rocks, and that pinkish color comes from that pink or salmon-colored feldspar called potassium feldspar. So K feldspar, potassium feldspar, that is what gives that rock that pink color. Next we have the identification chart down here, and I'll blow it up here. I talked about this chart in the Rocks 9b.1 video, so you should watch that if you haven't. And here's the sedimentary rock chart. Now we're not going to look at all of the rocks, we're going to look at the numbers I've given you here. This is the number of samples that you have. So you have one conglomerate, one breccia, one quartz sandstone, etc. And that should make it easier for you to determine what rocks you have. If you have a PCC rock kit, then here are the sedimentary rocks. There are 3 of them that we're not going to include in lab, but we're going to include these 4, and remember we have videos for all of these. So let's do S2 together. Remember, you go to the modules, go to the mineral and rock videos, and in this case you're going to select the sedimentary rocks. Video S2 is 49 seconds long, and here you can see very clearly lots and lots of shells that are all very close together. The person that narrates this video puts a drop of hydrochloric acid on it, and we see that we get bubbles of carbon dioxide. So this is definitely made of calcite. So let's fill out our chart. We have shell fragments, that's the texture. We definitely have calcite as the composition. And so since we have calcite, we know we're in this part of the table. We're under chemical sedimentary rocks, and in this case we could say biochemical because we know we have shell fragments and that's biological. And then we have to look at our choices. I've already made it easy because there's only 3 to choose from. There's a crystalline limestone, which does not have fossils. There's a coquina, which has visible shells that are loosely cemented together. And there's a fossiliferous limestone that has shells and it's well cemented. Well, it turns out if you tap this rock, it would fall apart. It is loosely cemented. So this happens to be the coquina limestone. I put LS for limestone. Let's do S8. We look at the video and we can see that there's lots of different rock fragments within the rock. They're rather large and they do seem to be rather angular. They're not well rounded. So we're going to say that the material in the rock is coarse, it's larger than 2 millimeters, and it's angular. It seems to be what we would call gravel. If any of the rocks that you look at are limestone, the person doing the video tends to use a little hydrochloric acid to show you that it is made of calcite. So this is going to be a detrital rock over here, and it's going to be a breccia because the mineral fragments are angular, they're not well rounded. Let's do S20. Here's the video for S20, 43 seconds long, and this is a very fine-grained rock. The person in the video mentions that it does not react to hydrochloric acid, so it's not a crystalline rock. And in fact, he gets out his hand lens and he looks very closely. And this is not a very good image to see, but there are little mineral grains in here. So this is a very, very fine-grained rock. We're going to call them silt-sized particles. This is a detrital rock, and we're going to call it a siltstone. We've already eliminated 3 of these, so you have 7 left to figure out, and those are indicated with my big number 1s here. The next page shows you a bunch of depositional environments that sedimentary rocks occur in, and these are important. Certain kinds of rocks form at beaches, in caves, in sand dunes, inland seas, etc. So you want to make sure to read each of these and understand that these sedimentary rocks are telling us about the environment in which they formed. Beaches, for example, have sand-sized particles. We wouldn't expect a coral limestone reef at a beach. We would expect a coral limestone reef to indicate shallow water ocean conditions. The next set of questions, activity 7, are related to this picture, and they ask you to identify the environment for each of these rock types. I don't recommend just using the letters A through L. It's not very informative when you go to review. Rock gypsum, for example, if you see here, is D. So you could put D, but you could also put inland seas and lakes in arid regions. So go ahead and try these. Number 2 and 3, you have to give a little thought to, but I think you can answer these. Finally, metamorphic rocks. We have a description here of metamorphic textures and how foliation develops an alignment of minerals as rocks experience intense heat and pressure. Those are foliated rocks, and we also have non-foliated rocks, such as marble and quartzite, that do not have those linear features. Here's the chart for the mineral identification, and again, I go over this in video 9b.1. And here's our chart. If you have a PCC rock kit, we're going to look at most of these metamorphic rocks, but not all of them. So here are the ones we're going to look at, and let's take a look at M3 together. Oh, and also, here's what you have to choose from. So here's M3 video, and the person doing the video points out these large pink feldspars and these black minerals that are all in alignment. And so that is foliation. It's coarse foliation. The minerals are pink feldspar and dark minerals. Do your best to try to identify them, and that gives us a gneiss. And so we move now to one of those. So try your best at each of those. Finally, I'm going to zip through this. I don't have time. Here's number 4. Here's number 5. Do your best and rock on.